Good morning children. In this video, we are going to see some important topics. Okay. The first one is about matter. You know very well, matter is everywhere. We are made of matter only. The air we breathe is made of matter. Matter is nothing but anything which occupies space and has weight are called matter. Matter is indestructible. Okay, what is the meaning for indestructible? We cannot destroy it. Okay, we cannot destroy the matter. Not able to destroy. That is the meaning for indestructible. So, matter cannot be destroyed. Matter can neither be destroyed, nor can matter can neither be created nor can be destroyed. We cannot destroy the matter. Also, we cannot create the matter. Right? So, matter is indestructible. Indestructible means not able to destroy. We cannot create matter as well as we cannot destroy the matter, but we can transform one type of matter into another form, right? So what is meant by matter? Matter is anything which occupies space and has weight, right children? Good. Next one about energy. Energy is the capacity or ability of doing work. Okay. So energy is the capacity or ability doing work. There are different forms of energy such as heat energy, light energy, sound energy, thermal energy, like that. Energy can neither be created nor can be destroyed, but you can transform one type of energy into another type. Right children? So what is meant by energy? Energy is the capacity or ability of doing work. Understood? Good. Next one, classification of matter. We can classify the matter into three types. Okay. So one is matter can be classified into three forms or three states. One is the solid state. Next one is the liquid state, and the last one is the gaseous state. Each and every state has some special characteristic properties. Okay. And what are the general properties of solid? If you look at the solid, solids are rigid in nature. Okay, solids are rigid in nature. We cannot compress the solid. It is very hard in nature. Next one, solids have fixed volume. Okay, solids have fixed volume, and solids cannot be squashed. What is the meaning for squashed? Squashed means crushed. Okay, solids cannot be squashed. Squashed means crushed. So, what are the general properties of solid? Solids are rigid in nature. Solids have fixed shape and fixed volume. Okay, so this scale is nothing but a solid only. This scale has some fixed shape, isn't it? So, solids have fixed shape and fixed volume. Solids cannot be squashed. Next, we can see about the liquids. Okay, liquid state. Generally, liquids are not rigid in nature. Okay, it is not hard like solid. So, liquids are not rigid in nature. Liquids have no fixed shape. It takes the shape of the container, right? So, liquids have no fixed shape, and the liquid state has fixed volume. Okay, liquids have fixed volume, but it has no fixed shape. And the last one is liquids cannot be squashed. You cannot crush the liquid, right? So, liquid state it is not rigid in nature. Liquids have no fixed shape, but it has fixed volume. Liquids cannot be squashed. Okay. Next we can see about the general properties of gaseous state. So first one, gases are not rigid in nature, right? actually. So it is somewhat soft in nature. It is not hard like the metal that I will tell you in the properties, general properties of metals and non-metals. So what are the general properties of gaseous state? Gases are not rigid in nature. Gases have no fixed shape, no fixed volume, but we can square shape. Okay, so these are the general characteristic properties of solids, liquids as well as gases. So next we can move to mixture and the types. What is meant by mixture? In chemistry, mixture is a substances made of two or more separate components or materials. Okay, mixture is nothing but a composition of two or more things or two or more substances. Okay, two or more substances combined together, then it forms a mixture, right? So mixtures can be classified into two types. One is the homogeneous mixture and another one is the heterogeneous mixture. What is the difference between homogeneous mixture and heterogeneous mixture? If you take the homogeneous mixture, here the components, that is the composition is uniform throughout the mixture. What are the components we are adding? All the components uniformly gets distributed. Okay, this is called the homogeneous mixture. So what example we can give for homogeneous mixture? Salt dissolved, that is common salt dissolved in water, sugar dissolved in water, methyl alcohol dissolved in water, and these are some of the examples of homogeneous mixture. Okay, homogeneous mixture means here the composition is uniform throughout the mixture. That is components, what are the substances we are adding, all the substances uniformly gets distributed. In that case, we can say it is a homogeneous mixture. Next one, heterogeneous mixture. Heterogeneous mixture means here, in this mixture, the composition is not uniform, okay, throughout the mixture. Here the composition, that is the components, the substances, what we are adding will not get dissolved completely. For example, we can say sand and water, cement and water, pepper and salt. These things will not get evenly, will not get mixed. Okay, so the components will not get uniformly distributed. The composition is not uniformly distributed. Then it will come under the category of heterogeneous mixture. Okay, so what is meant by mixture? In chemistry, a mixture is a material made of two or more different substances. We can classify the mixture into two types. One is the homogeneous mixture and another one is the heterogeneous mixture, right? So next we can do the symbol. Okay. So in chemistry, symbol stands for some meaning. Not only in chemistry, even in mathematical terms also we are using like addition symbol, subtraction, multiplication, division, like that we are using. In the same manner, we are using the symbol in chemistry. Symbol stands for some meaning. Okay. In chemistry, an element can be represented by using a symbol. Okay. So element can be represented by using a symbol. Symbol means an element can be represented by using a symbol. This is called a symbol. So it stands for some meaning. Okay. Next one, a symbol in nowadays we are using many elements. We are calling some elements by using the name of a symbol only. Okay. For example, if you take oxygen element, it has one symbol. That is, its symbol is O. That is capital O. We have to put. So in the periodic table, nearly 118 elements are given. So all the 118 elements are represented by using symbol only. Each and every element is represented by a symbol. So some of the elements we can see now. Here the side element is given and its symbol is also given. So a carbon element, its symbol is C. The first letter, it should be in capital letter, right? Second one, for hydrogen element, its symbol is H. Third one, N. Next one, for oxygen element is represented by O. Okay, all the first letters you should use the uppercase, that is capital letter only. And for iodine element, the symbol is I. For some elements, we will use the first two letters. Okay, first initial letter as well as second letter. For some elements, we take first letter as well as third letter as symbol. For example, see, these are some of the elements and these are the symbol of the particular element. For barium element, its symbol is Ba. This is the first letter also we are using as symbol. Also, we take the second letter as symbol. Here in this case, you have to remember one thing. The first letter always we should use the uppercase, that is capital letter, and second letter it should be in the lower case. So, for barium element, its symbol is Ba. And second one, silicon element, the symbol is Si. S capital letter and I small letter. Third one, argon element, its symbol is Ar. Okay, A capital letter and R small letter. For argon element, the symbol is Ar. And for chlorine element, the symbol is Cl. For magnesium element, the symbol is Mg. Here we are taking two letters as symbol, right? Some elements can be named by using Greek or Latin names as their symbol. Okay, also we are using the symbol, but the Latin name as well as Greek name we are using for that particular elements. Some of the examples are, if we take the sodium element, okay, its Latin name is natrium, 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 and its symbol is Na. Okay, so for sodium element, its Latin name is natrium and its symbol is Na. Next one, copper element, its Latin name is cuprum and its symbol is Cu. Next one, for silver element, its Latin name is argentum and its symbol is Ag. Next one, gold element, its Latin name is aurum and its symbol is Au. Okay, so these Latin names and all you should remember, right children? Next, some elements can be named by using scientist name as well as color name, planet name, god name, like that. Okay, some of the examples are, see, the name is americium. Okay, the name of the element is americium. Its symbol is Am. Actually, this name derived from the country America. Okay. So next one, nobelium. Nobelium, element name is nobelium and symbol is No. This name derived from the scientist name Alfred Nobel. Okay, he discovered dynamite. Alfred Nobel. Next one, mercury element. Its symbol is Hg and it's derived from god Mercury, mythological character. Next one, plutonium. Its symbol is Pu. It derived from planet Pluto. Okay. And the next one is uranium element. Its symbol is U and it's derived from Uranus planet. Okay. So some elements are being named by using scientist name, god name, color name. If you take iodine element, its color is violet. Okay. So based on their names, they have given the symbol as well as element name, and they have mentioned that from where it is derived from, name, scientist name, or otherwise color name or a god name based on a planet, like that. Some elements are being named. Understood, children? Right. So next we can move to classification of elements. Okay. Generally, elements can be classified into metals, non-metals and metalloids. Okay. So actually metals can be identified by comparing its elements. Generally elements can be identified by comparing its properties with the general properties of metals, non-metals and metalloids. In this way, they have segregated into these things will come under metals, these elements will come under non-metals, like that they about metals. Many metals that we use in our daily life. For example, iron, copper, gold, silver, aluminium, nickel. These are some of the metals that we use in our daily life. Okay. There are some general properties, that is characteristic features of metals. What are the general characteristic features? First one, generally metals are solids under normal conditions of temperature and pressure. Okay, but if you take mercury, even though mercury is a metal, it is a liquid quantity. Generally metals are solid. The exception case is mercury, because mercury is a liquid, right? And most of the metals are hard in nature. Okay, most of the metals are hard in nature, and generally metals are shiny in nature. The typical shine of the metal is called the metallic luster, right? And metals have high density, they have high melting point, boiling point. Metals generally conduct heat and electricity, and also on heat metal produces sound. So actually this property is generally used in temples for making bells, okay, temple bells, right? Next, metals can be beaten into very thin sheet. Okay, this tendency of metal is called malleability. Okay, for example, we can take aluminium metal. We can make that aluminium into very thin sheet. This property is generally used for making silver foils. We can transform the aluminium into silver foils by using this property, right? Next, metals can be drawn into very thin wires. For example, we can say copper wires, right? So these are some of the general properties of metals. Next, we can move to the uses of metals. Copper is a metal. So copper generally is used in electrical wires. Okay, copper is used in electrical wires, and aluminium is also used in electrical wires, and also it is used in aerospace industries, and also it is used in cable wires. And iron is used for the construction of buildings, roads, bridges, and also it is used for engine parts. Okay, and mercury is used in thermometer. You know very well. Mercury is used in thermometer as well as in barometers, because because of its high density. Okay, because of its high density, mercury is used in thermometer as well as in barometer, right? Next one, gold and silver are used in making jewels, and also it is used for decorative purposes, right? So these are some of the uses of metals. Next, we can discuss about non-metals. Okay, non-metals, that is generally gases will come under non-metals. Some of the non-metals are oxygen, nitrogen, hydrogen, sulfur. These are some of the non-metals, right? And come to the general properties of non-metals. Non-metals occur in all the three states of matter. Just now we discussed about the three states of matter, isn't it? What are the three states? Solid state, liquid state, and gaseous state. So, non-metals occur in all the three states of matter. For example, if we take the sulfur and phosphorus, it occurs in the solid state, whereas bromine occurs in the liquid state, and hydrogen, oxygen, nitrogen occurs in the gaseous state. So, non-metals occur in all the three states of matter. Understood? Right. Next one, non-metals are soft in nature, but the exception case is diamond. Diamond is a non-metal. Actually, we are getting this diamond from carbon. Okay, this diamond is the hardest naturally occurring substance. And non-metals has low density, non-metals has low melting point and boiling point. Okay, non-metals are not malleable into nature. We cannot we cannot hammer by using thin sheet. We cannot make them into very thin sheet. It is a non-malleability in nature. And also non-metals are non-ductile in nature. Okay, non-ductile in nature. In that case, ductility means what I told you. Ductility means we can make the metal into very thin sheet, but non-metals are non-ductile into nature. We cannot make it into very thin sheet. But carbon fiber is highly ductile in nature, right? Non-metals generally do not conduct electricity, but graphite is a non-metal. Graphite conducts electricity. Okay, and non-metals do not produce sound on heat, right? So these are some of the general characteristic properties of non-metals. Next, we can discuss about the uses of non-metals. Okay, diamond already I told you it is used for making jewelry and also for cutting, welding purposes also we use. And graphite is mainly used in pencil lead. Okay, phosphorus is a non-metal. It is used in matchbox. And sulfur is used as an explosive, that is gunpowder, and also for vulcanization of rubber. Nitrogen is used for the manufacture of ammonia, that is for fertilizer purpose. Hydrogen is used as a rocket fuel. Chlorine is used as a bleaching agent, right? So these are some of the uses of non-metals. Understood, children? Shall we move to the metalloids now? Right. Next, let me discuss about metalloids. What is meant by metalloids? Metalloids means the elements which exhibit both metallic property as well as non-metallic property. Okay, if the element exhibits both the properties, that element exhibit metallic property as well as non-metallic property, then those elements will come under the category of metalloids, right? Metalloids means that element exhibit metallic character as well as non-metallic character. Example, we can say boron, silicon, germanium, arsenic, polonium. Okay, so these are some of the examples we can say for metalloids. Understood, children? Shall we move to the next one? Right. So next we can move to compounds and its types. What is meant by compound? Already I told you, compound is composed of two or more separate elements, isn't it? Right. Compounds can be classified into organic compound as well as inorganic compound. What is the difference between organic compound and inorganic compound? If you take the organic compound, compounds which are obtained from the living sources, okay, then we can call it as organic compounds. For example, proteins, carbohydrates, lipids, sugars, fats. These are some of the examples of organic compounds because these things we are getting from living things, plants or animals, right? Next one, inorganic compound. Inorganic compounds means here the compounds which are obtained from non-living sources such as rocks and minerals. That is called an inorganic compound. For example, we can take baking powder, right? Baking powder, sodium carbonate, as well as chalk paste. These are some of the examples of that is inorganic compound because those compounds which we are getting from non-living things. Okay. So what is the difference between organic compound and inorganic compound? Organic compound means compounds which are obtained from living sources, whereas inorganic compound means compounds which are obtained from non-living sources. Okay. Both organic compound as well as inorganic compound obtained in all the three states of matter, whether it is solid state or liquid state or gaseous state. Both compounds obtained from all the three states. Got it, children? Right. So next we can move to fundamental quantities. while mentioning the fundamental quantities, we have to mention the unit as well as symbol is very important, right? First one, length. Length is measured in meter. So what is the unit? M, small n. Okay. Next, mass is measured in kilogram. What is the unit? Kg, right? Next, time is measured in second. Its unit is S. Temperature is measured in Kelvin. Its unit is K. Capital K we have to use because Kelvin is the name of the scientist. Next, electric current. It is measured in, its unit is ampere. Okay. Electric current is measured in ampere and its unit is A. Luminous intensity, candela, its unit is CD. Next, amount of substance, mole, its unit is MOL. Okay. So, these fundamental quantities are very important. Some of the fundamental quantities are length, mass, time, temperature, electric current, luminous intensity, amount of substance. Apart from this, you have to learn about the unit also and symbol also, very important, right? Good. Next, chemical equation. In chemistry, chemical equation is the shorthand representation of a chemical reaction by using symbols and formula. Okay, by using symbols and formula. It has two components. One is the reactant and another one is the product. Okay. What is the difference between reactant and product? Reactant means the component which has take part in the chemical reaction, whereas product means the substance which is formed during the reaction. The component which is formed in the reaction are called product. That's the difference between reactant and product. Okay. So chemical equation is the shorthand representation of a chemical equation by using symbols and formula. During chemical reaction, we use symbols as well as formula. We will use, and it has two components. One is reactant and another one is the product. The difference between reactant and products are reactants are the substances which take part in the chemical reaction, whereas products are the substances which are formed during the chemical reaction. Okay, right? Shall we move to the last one, children? Good. Next one, periodic table. Okay. So in the periodic table, already I told you, 118 elements, 118 elements are present in the periodic table. Among this 118 elements, majority of the elements are naturally occurring elements and some of the elements are synthesized in the laboratory. Synthesized in the sense produced in the laboratory. Okay. Here all the elements are arranged. Okay. Arranged in the periodic table in a systematic manner. Okay. In a systematic manner. The modern atomic theory states that the physical and chemical properties of the elements are the periodic functions of their atomic number. All the elements they exhibit the periodic functions with the atomic number. Each and every for each and every element, its atomic number is given, and the elements are arranged based on their increasing number of the atomic number. Okay. So the physical and chemical properties of the elements are the periodic functions of their atomic number. Here in the periodic table, all the elements are arranged in rows. Okay, rows and columns. Okay, rows and columns, and they mainly exhibit the general properties of the elements. We can know we can learn lot of information about each and every element. What are the special physical properties? What are the chemical properties? What are the gaseous elements? What are the solid elements? What are the liquid elements? Everything we can know about by using the periodic table. Okay. Here you should know about periods and groups. What is the difference between periods and groups? These two terms are very important in the periodic table. In the periods means the horizontal rows. Okay, the horizontal rows in the periodic table are called periods. There are 7 periods in the periodic table. Okay, the horizontal rows, the periodic table are called periods, and there are 7 periods like that. 1, 2, 3, 4, 5, 6, 7. 7 periods in the periodic table. And the vertical column from top to bottom, okay, are called the groups. Nearly there are 18 groups in the periodic table. These two things are very important. One is about the periods and another one is about the groups. Okay, periods means what? The horizontal rows in the periodic table are called periods. There are 7 periods in the periodic table, and the vertical column from top to bottom are called groups. There are 18 groups in the periodic table. Right, children? So, what are the things we discussed today? About energy, matter, and then classification of matter, mixture and its types, symbol, classification of elements, compounds and its types, fundamental quantities, chemical equation, followed by periodic table. So, all the things you have to go through. Many questions you will be getting for the test from this portion. Okay, all the things are very important. Many definitions also I told you. Apart from that, I told you about the fundamental quantities. This is also very important. Many one more question you will be getting from this fundamental quantities. Okay, so all the things you have to go through, children. The remaining things we will see in the next video. Thank you, children.